everyone, I'm Samantha Peterson, Marketing Manager here at RM Young Company, and today I'm thrilled to welcome Dr. Baker Perry. Dr. Perry is a professor of climatology and the Nevada State Climatologist in the Department of Geography at the University of Nevada, Reno, where his research focuses on high mountain weather, snow and ice processes, and how climate change is affecting critical water towers around the world. He has led or co-led groundbreaking expeditions to some of the planet's most extreme environments, including installing the world's highest weather station on Mount Everest as part of the National Geographic and Rolex Perpetual Planet expeditions, stations that have transformed high elevation climate science as we know it. Most recently, Baker led the Aconcagua Weather Station Network installation in the Andes, bringing valuable observational data from near the summit of the highest peak in the Americas to help improve understanding of water availability in the face of long-term drought. We're proud to partner with him and his teams to collect data from some of the most hard-to-reach places on Earth, advancing both science and our understanding of global weather systems. I'm looking forward to talking with him about that expedition and what the data from Aconcagua can tell us. Welcome, Baker. I've been so looking forward to chatting with you today.
Well, thank you so much, Samantha. It's a real pleasure to have the opportunity to connect and chat and especially talk about some of the science and some of the important data that your sensors are allowing us to collect in these locations.
Yeah, absolutely. It's been such an honor and privilege working with you on these expeditions, and I'm really excited to hear more about it. To start, can you just give us a high-level overview of the Aconcagua Weather Station project and what the research team set out to accomplish?
Yeah, the Aconcagua project, which we call WAYRA, WAYRA, which translates as wind in Quechua, one of the native indigenous languages there, is a really big collaboration with the National Snow, Ice, and Environmental Science group in Argentina called IANIGLA, and multiple other partners, including RM Young and scientists from the United States and the United Kingdom. And it's been, a huge collaborative effort. And the goal is to improve our understanding of the atmospheric processes, the weather, the climate that's really driving the changes we're seeing with snow cover and glacier ice. And these are very important water towers that sustain communities downstream, including the major city of Mendoza in Argentina. And then just over the border, of course, there's the really important metropolitan area of Santiago, Chile. And so these are two very, very important urban areas that directly depend on water coming off of the high Andes. And we really have not had the observations to fully understand what's happening up there, and in particular, how the changes we're seeing with our climate around the region and more broadly around the world, how that's ultimately going to impact water resource availability in the future. And so that was the main motivating factor. There's also an interest, of course, in climber safety. Aconcagua is a very popular peak to climb just because it's the highest in the Americas and one of the 7 summits. And so there are a lot of people on the mountain, and there are a lot of guides and porters that bear the brunt of exposure in the extreme weather, ferrying loads and caring for clients. And so that's a particular motivation, is to really improve the weather forecast to make the climbing safer. And and so the other really neat thing about Aconcagua is that there's it's such a high mountain that that we have a nice vertical transect going all the way from base camp up to Camp 2, up to the summit, and then down to what's called Plaza Argentina on the kind of other side, on the east side of the mountain. And so that was a really appealing part of this, is not only do we get high quality observations from the summit, but we have multiple points along the way. And of course, that's really important for our understanding of what's happening as weather systems move through, and just seasonally and annually through the year. So wind, of course, is the big focus, and wind is important for bringing the storms. Mainly the big storms come off of the Pacific, and so being able to characterize the flow and where these storms and air masses are coming from is critical for the wind measurements. And then, of course, the wind is also very important in moving the snow once it does fall. And also it plays a major role in the sublimation, the loss of the snow and conversion directly into water vapor, which is very common in this part of the world because it's so dry and relatively cold that a lot of that snow does not melt, it sublimates. And so having the quality wind measurements are very important for determining those aspects as well.
Yeah, absolutely. Thank you. That was a fantastic overview. And I'm curious, since wind is so important, what made you choose RM Young Company's wind monitors for this project?
Well, yeah, I have a long history of working with the RM Young wind monitors on mountain sites in other parts of the Andes. We've, of course, partnered with you all on Everest and Nepal, and also just other mountaintop stations in the Appalachian Mountains. And your products are very robust. They have brought back just very important data from these hard to reach locations. And so that has been, I think, a real important collaboration. And you all have also worked with us on some design modifications and to try to improve the survivability in some of these extreme locations. And so it's been a very valuable partnership in terms of our ability to test some of your products and then provide feedback and try to make improvements. And so these high mountain regions are some of the ultimate testing grounds for meteorological instrumentation, because you can't simulate this in controlled wind tunnel environments. And so we learn a lot from just putting the sensors out and of course analyzing the data, but also just having the direct visuals from when we go back, or when our team members are able to go back and check on the stations.
Yeah, absolutely. And we have so enjoyed our partnership with you, and we really appreciate all the help that you've given us too. Like, it's been a really great mutual benefit, I think. So thank you for that. And I'm curious, what special considerations go into installing instruments at that altitude and in those conditions? The severity of the weather and the height must have some kind of add a new challenge and difficulty to the actual installation itself.
Yeah, it's probably a number of challenges come to mind. I mean, one of the biggest is that we just have such a short window to work up there. I mean, we were just below 23,000 feet on the summit of Aconcagua, and not using supplemental oxygen. And so that's pushing the limits right there. And we're climbing from a camp much lower down. And so at best we have a few hours to work at the summit, and that's under the best conditions with ideal weather. And we were fortunate for the day that we installed the summit station last year in 2025. The weather was about as favorable as it gets. I mean, we were in the mid-teens Fahrenheit and relatively light winds, and so it made for um, very, very good working conditions. But even with that, we only had 3 hours or so to work because it's such a long day to climb to the summit. We left at I think 1 a.m. in the morning, and had to be back down to that high camp, what we call Camp 3, at before dark. And so we're very limited in just the time that we have. So that's one factor. The other is that, I mean, everything has to be carried up. And so we're very limited in just the overall weight of what can be transported to the summit. We split up the items among our team. We had some additional assistance from some high altitude porters. And so that is very different than being able to drive directly to a site or even fly in on a helicopter, because helicopters don't routinely fly up to this elevation on Aconcagua due to the very high elevation, low air density that we have there. So everything has to be carried up. And then because we're so limited in time, the installation has to be rehearsed and practiced so that all members of our team know exactly what to do, and we can work together quickly. We don't have time to troubleshoot, oh, where does this wire go, or this connector, or how does this sensor need to be oriented? How do we anchor the tripod? And so all this required some pretty extensive training and just practice with the full team. At base camp, we did that on multiple days. And then also, compared to kind of conventional, more typical weather stations, the stations we install at the highest elevations, they have to be pre-wired. And so things can be connected very, very quickly, especially with gloves. We don't have the dexterity. We're not able to use our fingers because of the cold, or really expose them either because of the cold, to connect individual wires to the data logger like we typically do lower down. And so there's a lot more kind of pre-planning and pre-wiring, in a sense, that has to be done at the factory with our partners, with you all and with our partners at Campbell Scientific in particular. And so that's I think an added consideration. And then just once we set the station up, we try to stay up there as long as we can, given the short window, just to confirm that it's transmitting successfully with the satellite telemetry. And that can be a little nerve-wracking at times, and you're just holding your breath. Okay, we've tested this. Everything is aligned, everything's connected. We want that confirmation that everything is working and transmitting successfully before heading down. And that's a real big that gives us certainly a lot more peace of mind that we're having transmissions coming down. Now, the other thing that is just very hard about these mountaintop installations is that they're only on Aconcagua, for example, there's only a couple months. It's really just from December to February, so 3 months maximum, that people are on the mountain, because the rest of the season, just the the weather's too severe and there's not the infrastructure in place for people to go up. So one of the things that happened on the summit station this past year is it stopped transmitting in June, and we weren't exactly sure why. The battery voltage and all the other sensors appeared to be okay, but we lost transmission, so we didn't know what the status of the station was until December, until the first climbers and guides made it to the summit, and we've got some photos, and what we immediately saw was that the GOES satellite antenna had been blown away, had been blown off. And so no wonder it wasn't transmitting. And then that gives us a very narrow window to, okay, this is what has happened. Now we've got maximum 1 to 2 months to come up with a plan to get the replacement parts, organize a small expedition, and try to make those replacements. And on Everest, it's even a tighter window because it's only 3 to 4 weeks a year that we have, and it makes it very difficult to to plan and to access and to conduct the maintenance on the stations. And so it's a very narrow weather window in general because of the season, and then we're at the mercy of the weather once our teams are on the mountain, because sometimes it's not favorable and it prevents even climbing to the stations. And then even if we are able to get there, sometimes it's snowing, it's windy, it's very less than ideal conditions. So those are just a few of the real challenges that we face in keeping and installing the stations to begin with, and then conducting the essential maintenance each year to keep them running.
Yeah, and you're going up later this week, right? For the maintenance.
I am. I'll be back on Aconcagua the last 2 weeks of February, and we'll be conducting essential maintenance on all of the stations from base camp all the way up to the summit. And we've got some important work to do at the summit to certainly replace that GOES satellite antenna, as well as make some other upgrades to sensors that have taken a beating over the winter up there.
Do you happen to know off the top of your head what the highest wind speed reading you've gotten is from up there?
Oh, that's a good question. I think we have seen well over 100 miles an hour. I think it's up to maybe 120 miles an hour. But we're in the process of analyzing the most recent data that we were able to get when a guide brought down the SD cards from the logger. So it's still work in progress.
That's very exciting. Is that data going to be available publicly anywhere? Can people go access it?
So the real-time data are available on our Yanigla website, the Argentine partners. And we are working on a publication for the Bulletin of the American Meteorological Society that introduces the network and that will report on the first year of data, and then we'll have including the 1-minute data available through that link when it eventually gets published.
That's fantastic. So is that the data? I know you mentioned in the beginning that hikers are using the data hopefully to make it a safer trail. Is that where they'll be able to access it?
So the real-time data are already accessible through Argentina when transmission's occurring. And so once we get this new replacement antenna up there, the data should be going directly to the site that's publicly available. And we can make sure you have that link to to share as part of this. And so climbers, the expedition logistics companies, the guides, the provincial park, which is run by the regional government of Mendoza, they all have access to the real-time data coming from, again, not just the summit when it gets up, when we get that antenna replaced, but also the lower stations too. And so that's a really important resource. And then from that, and we've done similar work on Everest, just by having the observations from these weather stations, whether they're transmitting in real time or not, we can establish these statistical relationships and bias correct the model forecasts that are coming in. And so that's something that we're working on doing already, and that's not necessarily dependent on even real-time data. The real-time data are very nice, but just having that point location, those measurements can already especially improve the wind and temperature forecasts coming from the global models. And so that's a big success from these stations already.
Have you seen anything in the data so far that surprised you?
Well, we were not able to put the station at the very, very summit because limited space and because of concerns of just the sheer number of people up there. So we had to go down a little bit off the summit. And that is great for longer term survivability and just making it less obvious and less likely that a climber or a client may inadvertently disturb it. But by being a little bit lower down, it's slightly more protected. So we're not seeing perhaps quite as high of wind speeds as we would be if we were really on the summit ridge or the summit itself. Plan A was actually to put it on the ridge, just south of the summit that is off of the main climbing route. But we went there first, but there was no good way to anchor it there. There's just a lot of just loose rock and kind of sandy soil, and so it was just not viable. So we had to go down and look for a second spot that maybe is not quite as exposed to the highest winds. And so yeah, I think honestly, I would say that I'm a little surprised we haven't been able to measure, haven't seen wind speeds a little higher than they are. But I think part of that could just be from the somewhat more sheltered location that we have.
Yeah, that makes sense. How many weather stations are there? How many sites are there on the mountain?
So there are 5 stations.
5.
There's 2 close to base camp. One of them is a special flux station that is able to measure the sublimation versus melt, so kind of the gas exchange that we're seeing there. And that's a very sophisticated system that's on the lower glacier, very close to base camp. And then there's another more precipitation focused station at base camp. And then at Camp 2, we have again, very comprehensive station with precipitation, wind, solar radiation, all of the key meteorological variables. And then the summit is much more simplified, scaled down just due to the obvious weight limitations that we have there. And then we have another one at Plaza Argentina down on the east side of the mountain. And so it's a really fantastic network to have this transect in elevation, but also that goes up and then over and then down on the east side of the mountain as well. So 5 stations in total, ranging from about 14,000 feet up to just below 23,000 feet.
That's very cool.
Yeah.
And I don't think I've asked yet, how many people were actually on the expedition with you?
Oh, yeah, I think we had 15 or so total on the expedition. Of course, not everyone went to the summit. On our summit team, we had a total of 6 people is what I recall. And so it was a much smaller team going to the summit.
How long did it take you to get from base camp up to the summit?
Well, yeah, we from base camp, it was one day to camp 1, and we spent a night there and then moved up to camp 2 the next day. Then we had 1 or 2 rest days at camp 2 while we also built the camp 2 station, and then we moved to camp 3. And then, so it's pretty much, that's almost a week, just going up from one camp to another. And it's important we do that to acclimatize. And of course, we had work we were doing in particular at camp 2 while we were recovering and acclimatizing and waiting for that weather window for that optimal weather window to allow us to go to the summit.
That's so cool. I'm curious, what is the most memorable moment on the mountain for you personally?
I'd have to say the sunsets from Camp 2 were particularly memorable. It's just Camp 2 has this almost 300-degree view to the north and to the west, and just the sunsets up there were absolutely phenomenal, very memorable. And then so that was a highlight. Another really memorable part was just the teamwork and the fact that on these expeditions, and on Aconcagua in particular, it's critical to work together as a team. Nobody can do this by him or herself. It requires incredible teamwork and training and camaraderie to get the work done. And so when we return to the base camp from the summit, there's this real sense of accomplishment and satisfaction and incredible camaraderie that we see from the collective work that is taking place. And it's it's not always easy because there are certainly cultural differences, language differences, and so that those are real important opportunities to collaborate and to overcome some of those some of the many obstacles that we encounter on expeditions.
What's the biggest takeaway that you hope people understand about this project and its importance?
The biggest takeaway, I think, is just how important these measurements are for understanding climate and improving our projections of future water resource availability. I mean, I think water is a key thing, and it may seem, a bit odd that wind is so connected to water, but they are. I mean, the wind, and especially these measurements, high quality measurements of wind from the summit and at the lower elevations on Aconcagua, are incredibly important in understanding where moisture is coming from, how much snow is being scoured away, moved, and then ultimately how much of that snow and ice is being lost through sublimation and also melt is playing a role. But anyway, it's all connected to water. So water is the important take-home point from the importance of this network, I would say. Absolutely.
Great. Well, looking in the future after your Aconcagua trip later this week, what adventures do you have in the pipeline? I heard you might have another expedition coming up.
We are planning to be back on Mount Everest in April and May, conducting essential maintenance on those weather stations and making some upgrades to the South Call station as well. So yeah, that's coming up very quickly. And we're trying to ensure that these stations that we've installed, the networks we've installed, can operate as long as possible to continue to add to the climate record, to answer these really important questions, and to also be there to support real-time observations for climber safety on the mountain as well.
Yeah, that's great. Well, hopefully after your trip to Everest, we can chat again and we can get an update on those Everest stations. That would be awesome.
Absolutely. Would be happy to do that.
Great. Well, thank you so much, Baker, for joining me today. It has been really awesome hearing about your adventures and all of the very cool data that you're collecting to make the world better. So thank you for everything you do.
Well, Samantha, it's always a pleasure, and I really appreciate this partnership with RM Young, and I look forward to continuing to push your sensors to their limit and learn as much as we can from these really important places around the world.